All right, welcome back. We're going to finish this test 16A with 11 through 20. Stick with me.
Flack math! Give me some math and I'll give you some flack. Flack math!
Number 11. Mary is at it again. She's painting a floor of a gazebo that is in the shape of a regular hexagon with 12-foot side lengths. What is the total area that must be painted? All right, so we're gonna just use our apothem and perimeter formula for area. So area equals 1/2 AP, okay? So we're gonna plug that in. So what is it, a hexagon? We just did this one on our last test. So remember, our hexagon looks like this. If this is part of it, we need the apothem, which is this length right here. So if the whole side length is 12, that means this is 6. So that means this is 12, but this is 6 radical 3. So that's our apothem. All right. So A equals 1/2 apothem. So 6 radical 3 times our perimeter. How do you find the perimeter of a hexagon, regular hexagon? Well, the length of the side times 6. So 12 times 6 is 72. So remember, perimeter is 6 times 12. Okay. All right. 1/2 times 6 is 3 times 72 is 216. That radical 3 on there. Okay. So what is it? 12 foot. So square feet. Boom. Number 11, good times. Calculate the lateral area of a right cone with a radius of 4 inches and a slant height of 10 inches to the nearest 100th square inch. All right, so this is gonna be, remember our lateral area is just 1/2 PL. So P stands for perimeter, and in our case with a cone, it's gonna be 1/2 circumference times L, okay? So let's figure that out. 1/2 pi DL. So pi D is your circumference. 1/2 pi D, well 1/2 of D is R. So we're gonna say pi RL. All right, pi is 3.14, R is 4, and L is 10. So 3.14 times 40. So that's 125.6 square inches. The nearest 100. So 0.60. So there it is. Book says something else because they use bigger pi decimal, whatever. All right, let's do number 13. The vertices of a triangle are -3, 0. Okay, so there's E. -2, -3. So there is F. And 1, -2 is right here. So that is G. Okay? We're going to find the image of EFG after the translation x plus 2, y plus 3. So basically what that means is we're going to move right 2 and then up 3. Okay? So whatever your x is, add 2. Whatever your y is, add 3. So that means our E prime is going to be add 2 to x, so that's -1. Add 3 to y, so that's going to be 3. All right? Your F prime is add 2 to -2, which is 0. Add 3 to -3, which is 0. Your G prime is going to be add 2 to 1, which is 3. Add 3 to -2, which is 1. So that's what that's going to look like. So let's see here. This is my normal triangle. So we are going to translate it. So let's just change the color. Sorry, I should have done that before. So -1, 3 is right there. So that's E prime. 0, 0 is right there. So there's F prime. And G is 3, 1. So that's right there. That's G prime. So this is what this looks like. Pretty cool. All right. So, and look, you can look at each individual point. See how I went right 2, up 3, right 2, up 3, right 2, up 3. Boom. Cool. So make sure you show the pre-image and the image of the same on the same coordinate grid. Boom. Check. Done. Good. All right. Number 14. Find the volume of a tetrahedron. Ooh. So a tetrahedron is a regular triangular pyramid. Okay. So here's what that looks like. So it's, you kind of have this thing, then it's like that pyramid thing that Preston always tries to solve or whatever. So since it's a pyramid, it's instead of area of base times height, it's 1/3 area of base times height. Okay? All right, so how do you find the area of the base? Well, that is just a regular triangle. Well, we could figure out what that is, but they give it to us. How boring is that? So that's 6.6 and a height of 3.25. So boring. So that's 2.2. 1/3 of 6.6 is just 2.2 times 3.25. So let's do that real quick, and we get 7.15. So that is cubic centimeters. Okay, don't forget, you can use this formula for a pyramid on the test. So write it down somewhere so you can look at it. Okay, number 15, find the lengths of the sides of kite A, B, C, D, round to the nearest 10th. All right, so here's what you know about kites. Well, it's not like this is a third of that and a third of that or whatever, but you do know that these diagonals of a kite, the diagonals of a kite are always perpendicular. So let's fill in the blanks first. If this is 3, this is 3, because this longer segment is always going to bisect the shorter diagonal. The longer diagonal is always going to bisect the shorter diagonal. So this is cutting that in half. That's cool. So now we can use the Pythagorean theorem to figure out this. This is the square root of, let's see, 4 plus 9 is 13. So this is the square root of 13. This is square root of 9 plus square root of 25. So that's the square root of 34. So this is going to be the square root of 34. Same problem. And this is the square root of 13. So really, the lengths of all the sides, and we're going to round to the nearest 10th. So we do have to actually calculate that. So let's do that. So 13 square rooted is nearest 10th 3.6. And 34 square rooted nearest 10th is 5.8. So this is 3.6 and this is 5.8. So I mean, technically you should do this. AB is approximately 3.6. BC is approximately 5.8. CD is approximately 5.8. And AD is approximately 3.6. All right, now I feel better. Find the surface area. Oh, this is easy. Surface area of a sphere is just 4 pi r squared. So SA of a sphere, you can write this down, is 4 pi r squared. So it's like 4 circles. Okay, so 4 times, so we're going to keep it in terms of pi, so keep that pi there. And what's our radius? It's a 3-foot radius, so 3 squared. So this is 4 times 9 times pi, which is 36 pi. And this is exactly 36 pi square feet because it's surface area. You don't have to say approximately because you're using pi as pi, which is the exact answer for pi. Okay, number 17. Find the lateral area of a cylinder with a radius of 10 inches and a height of 15. Keep it in terms of pi. All right, well, let's just draw it just because it makes us feel better. So the lateral area is just this long rectangle, right? Well, what's that long rectangle? If you unwrap it, what's that length? That's the circumference, which is pi d. And then the height they give us is 15. So that's the height, that's the length, and that's the width of that big triangle. So that's just the lateral area. How do you find the area of a rectangle? Multiply. So it's just pi d times 15. Well, what's d? Well, the radius is 10, so the diameter is 20. So that's going to be 20 times 15, which is 300 pi. And this is area again, so square inches. Okay, number 18, 3 more. Here we go. The rule for the number of line segments, L, between n non-collinear points in terms of the number of line segments between n-1 points, denoted L n-1, is L of n equals L of n-1 plus n-1. How many line segments can be drawn between 8 non-collinear points? This is just silly. So we're just gonna plug in our 8 for n, okay? That's not bad. All right, so here's the equation that we're asked to use. L of n equals L of n-1 plus n-1. Okay, so since n is 8, we're gonna plug in that for 8, equals L of n-1, so 7, plus n-1, so 7. Okay, well this is interesting because we would need to know what L of 7 is. Well, what's L of 7? Well, L of 7 is L of 6 plus 6. Okay, well what's L of 6? Well, that's L of 5 plus 5. What's L of 2? Well, let's look at what L of 2 is. L of 2 is just how many line segments can be drawn between 2 non-collinear points. Well, how many is that? That's just 1. So that has to equal 1. All right, so if L of 2 is 1, that makes this 1. So L of 3 is 1 plus 2 is 3. Okay, so that makes that 3. So L of 4 is 6. That makes that 6. So L of 5 is 10. Okay. So that makes that 10. So L of 6 is 15. So that makes L of 7 21. So that makes this 28. Okay, that was kind of cool. All right, so this is an investigation, so guess what? It's gonna be extra credit. So if you do it, you get extra credit. If you do it right, not just if you do it. Not rewarding you for mediocrity. Number 19, rectangle ABCD has vertices. All right, we're gonna do this right this time. We're gonna do the vertices. -4, 6 is right here. So there's A. B is 2, 6 right there. Awesome. C is 2, 4. And D is -4, 4. All right, so there's our rectangle ABCD, beautiful. Reflect ABCD across y equals 3. So here's y equals 3 is right here. So y equals 3, boom, 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 boom. Okay, so what happens when we reflect it over y equals 3? We get this image. That's 1 over there. Here's D prime, A prime, C prime, and B prime. Okay? So that D is the same distance away from that line of reflection as D prime is. It's 1 unit, this is 1 unit. This is 3 units, this is 3 units. Okay? So let's identify the coordinates of the vertices of the reflected image. So A prime equals -4, 0. B prime equals 2, 0. C prime is 2, 2. D prime is -4, 2. Boom. Cool. All right, we're gonna add these equal vectors. So here's what it's doing. So this P vector goes right 1 and up 3. See how it goes right 1 and up 3. Well, Q vector goes right 1 up 3. And R vector goes right 1 and up 3. Okay, all I'm gonna do is add these together. So eventually when you put all these together, you could even draw it like this. Let's say this is my new origin here. My new origin is right here, and I go from here to here. And then I change the color because I can. I go from here to here. And I go from here to here. Well, where are you actually going? Well, that is right 3 up. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, all you're doing is adding the X's and adding the Y's. That's it. That's number 20. We're done. We're done with geometry. Congratulations. You survived geometry. I'm very proud of all of you. I know it's been a tough year, but you guys finished strong. That's awesome. So well done. That's it for Flack Math. I'll have some of you in Algebra 2 next year. Some of you are done with me. It's sad. It's sad to me, and I know it's sad for you. Cry yourself to sleep on your each pillow. Good job, guys.
Flack math! Give me some math and I'll give you some flack.